Okay, these notes are pH and pOH. pH is a measure of the hydrogen ion concentration. pOH is a measure of the hydroxide ion concentration. Now let's talk about the pH scale. We do use the pH scale with pH, obviously. But when you're measuring stuff, you've heard it before, hopefully. So let me draw it for you. So we got 0, and that goes all the way to 7, and then from 7 to 14. Anything in here is acidic. So anything that's from 0 to 7 is acidic. 7 to 14 is basic. Okay? In fact, lemon juice is in here, so at about a pH of about 3 is lemon juice. And then drain cleaner is a pH of about 12. So it's basic. Okay? Now we need to calculate pH and pOH. pOH is kind of the opposite. Well, pOH is the hydroxide ion concentration, where pH is the hydrogen ion concentration, and they are opposites. Okay, so they both add up to 14, 14 being the highest on the pH scale. So when you calculate your pH, you do have to subtract it from 14 to get the pOH, or to get the pH, if you have the pH, you subtract it from 14. So these two equations are quite necessary right here. So you're going to need to use those after you do the calculation. Now, calculation, you have to have a log-based calculator, okay, because these are logs. So pH is minus the log of the H plus ion concentration. It will be in molarity. So we're using molar solutions. Now, one of the things you're going to learn is that if there's a pH of, you put in minus log, and then it can be in two different forms. You can have the pH in the form of, let's say, 2.0 times 10 to the negative third, molar, or you can have 0.003, something like that, molar. You can use both those forms in the calculator. You just put in, as soon as you hit the minus the log, it comes up with a half a parenthesis, and then you put the number in, and then in the parenthesis, and hit enter. So it doesn't matter which form it's in. Okay, so what is the pH and pOH of a solution that has a hydrogen ion concentration of 1.0 times 10 to the minus 2? Okay, so pH, oops, I guess it would help if I had my pen. pH equals minus the log 1.0 times 10 to the minus 2. And it equals 2, which means it's acidic. Okay? And your pOH is 14 minus 2, which is 12. Okay? Pretty easy. At least I think so. This, by the way, is a special case. Whenever you have 1.0 times 10 to some power, that power is the pH or the pOH. Otherwise, if it's any other number besides 1.0, you just have to do the calculation. Okay, what is the pH and pOH of a solution that has a hydroxide ion concentration of 0.00306? Well, pOH is minus the log of 0.000306. And when you put it in the calculator, it comes out to be 3.5. Now, you can't tell whether it's acidic or basic yet because you've got the pOH, not the pH. So the pH is 14 minus 3.5, which is 10.5, which means it's basic. You can only use the pH to tell whether it's acidic or basic, not the pOH. Okay, so sometimes you have to calculate the hydroxide ion concentration and the hydrogen ion concentration. And we do that doing the opposite. Now, you can either use the second log function, which basically, if you look at your little calculator, is 10 with the x up in the, the x over in the exponent area, or use 10 with the little caret. Either way, it's the exponent. You're basically going to calculate the number by doing 10 to whatever the pH is, or 10 to the minus pOH. Okay? Okay, what is the hydroxide and hydrogen ion concentration of a solution with a pH of 1.98? Well, the first thing we need to do is calculate the pOH. So that's 14 minus 1.98, which is 12.02. Now, hydrogen ion concentration is 10 to the minus 1.98, which happens to be 0.0105 molar. And you can leave it in that form, or you can put it into scientific notation. It doesn't even matter. Times 10 to the minus 2. Okay? Your hydroxide ion concentration is 10 to the minus 12.02, which is 9.54 times 10 to the minus 13 molar. What is the hydroxide and hydrogen ion concentration of a solution with a pOH of 4.56? Well, the first thing we have to do is calculate the pH. So that's 14 minus 4.56. And when you do that, you get 9.54. Okay, so now, or actually 9.44, sorry. I can't subtract today. Try to do that in my head, and it came out wrong. So 9.44. Okay, so your hydroxide ion concentration is 10 to the minus 4.56, which is 2.75 times 10 to the minus 5. Your hydrogen ion concentration is 10 to the minus 9.44, which is 3.63 times 10 to the minus 10th molar. Okay, so I'm going to give you a chart on the next slide, and what I want you to do before I start talking, I want you to put it on pause, and I want you to try and figure out the chart on your own, and then I'm going to fill it in afterwards so you can check your answers. Okay, so here's the chart. So what I want you to do right now is put it on pause. Pause the video and then try and fill out the chart the best you can, and then check your answers. So what I'm just going to do is I'm going to quickly put the answers in. I might talk a little bit through it, but I'm mainly going to try and just put the answers so you can check yourself. Okay, so 14 minus 2.5 is going to be 11.5. And then H plus ion concentration, 10 to the minus 2.5 power. Oops, 10 carat minus 2.5 is 3.16 times 10 to the minus 3. And then pOH is 3.16 times 10 to the minus 12. So hopefully you got that. Now, these are whole numbers, so it's pretty easy. 10 to the minus 3 molar. Okay, so far you have hopefully these answers. If not, bring it in, like maybe circle it and bring in the question in tomorrow at school and I'll answer it. Okay, now this one is minus the log of 2.56 times 10 to the negative 6. And we get 5.59. 8.41. Now, to get the hydroxide ion concentration, we do have to use the 8.41. And unfortunately, my calculator that I'm using, because it only goes 9 digits, so it kind of rounded it to the fourth, was 0.000004. So I don't know for sure if it's 4.0 or 3.96 or 3.9 something, but I'll check it tomorrow in class. Okay, so now the last one's pretty easy. pOH is 4. This is 10.0 times 10 to the minus 10. Okay, hopefully you guys got these answers. If not, ask the questions tomorrow in class. So have a good rest of your weekend, and I'll see you tomorrow. Bye.